So this is a quick review of the route to the Band of Stability Lab for those of you who couldn't make it to the after-school session. So this first part of the lab is just background information, and you could use that information and should use that information if you have any questions on the different decay modes and stuff like that. This first highlighted link is the Band of Stability chart. And if you click and open that link up, you'll see here a chart that I actually created. And the blue dots here are the stable isotopes, with the y-axis being the number of neutrons, the x-axis being the number of protons. So if you took one blue dot, the y and the x values are the number of protons and neutrons for that stable isotope. And we're going to use that in the future. Here are some instructions about how to use that if you wanted to visually like step down to a stable isotope. But I'm going to skip that for now. The other thing that I wanted to say is to complete the route to stability. Here's an example. We have an unstable isotope, uranium 235. To get that radioisotope to be stable, so lead Pb 204 is a stable isotope, it has to go through all these steps. Each of these steps are unstable, result in an unstable radioisotope until you get to lead 204. So the first part of this lab was for you to do that route to stability for these two radioisotopes. But I'm going to skip that because this is just 2 points out of the whole entire lab. It seemed like it was kind of confusing to a lot of folks. So if you don't want to do it, just skip it, and it's not really going to hurt your grade very much. The bulk of the lab is to fill in this band of stability graphing sheet. So if you click on this link, you'll open up a blank spreadsheet, and I want to go over that with you in just a second. So this spreadsheet has 3 sections to it. The first section are isotopes that you will use this PhET simulation to determine whether that isotope is stable or unstable, and then fill out the rest of the chart, which I'll go into in a second. The second section here, these isotopes are all stable. So these green isotopes here, they're all stable. And so you'd fill out the chart accordingly. And lastly, whoops, this wasn't supposed to be filled in. Lastly, these kind of weird bluish, slate bluish isotopes, they are all unstable. And so you'll fill out the chart appropriately. So what do you mean by fill out the chart? Okay, here's the thing. You have your isotope here, and the first column, or the third column over, the first column that you have to fill in is the atomic number. As you guys know, the number of protons is the same as the atomic number. So if helium has 2 protons, its atomic number is 2. I'll just write that in there so we know, right? Helium-4, as you know, we've said it before, and Mr. Musio has covered it again recently. The 4 is the mass number, right? So if you have 2 protons and the mass number is 4, how many neutrons am I going to have? Well, I'm going to have 2 neutrons. 2 plus 2, 2 protons plus 2 neutrons equals the mass number, which is 4. 2 plus 2 equals 4. So you only fill in the neutrons under the stable or the unstable column. So one or the other is filled in, not both. Well, how do I know if helium-4 is stable or not? Because obviously you just saw me put it in the stable column. Well, what you have to do is go to the lab. So right under that big route to stability table is next to number 1 is a link that says open up the PhET build an atom simulation, you have to click on this, looks like play a video button, but it actually opens up the simulation, and then click on the atom. Once you've done that, I like to click open the plus sign for the mass number. That's just because I'm lazy, and it'll give me the mass number of whatever atom that I built. And also, this is important, on the lower side, click the stable/unstable option here, right? Stable/unstable. What will that do? That will tell me if my atom, my isotope, is stable or unstable. So I just drag the protons in there. One proton is, of course, hydrogen, which is not on the list. 2 protons is helium. Now, 2 protons and 0 neutrons has a mass number of 2, and it's unstable. But as you recall, the first isotope that I have is helium-4. To get to helium-4, I add 2 protons, because 2 means helium, and 2 neutrons. 2 protons and 2 neutrons, this simulation tells me that that is a stable isotope. So then happily, I had put the 2 neutrons in the correct column. Let me do carbon now. Carbon is 6 protons, right? 6 protons, carbon. I have 6 protons up here. You can count them, 1, 2, 3, 4, 5, 6. And on my spreadsheet, I want 6 neutrons. 6 protons plus 6 neutrons equals a mass number of 12. And the simulation tells me that carbon-12 is stable. So on my spreadsheet again, carbon's atomic number is 6, protons are 6, and it's a stable isotope. So in the stable column, stable, I'm going to put 6 protons. What's my mass number? 6 plus 6 equals 12. Now I'm going to go back to do carbon-14. Carbon-12 I have. How am I going to get to carbon-14? Well, I can't change the protons because that'll change the element. So I can add neutrons. So if I add 2 neutrons, that means I have 1, 2, 3, 4, 5, 6, 7, 8 neutrons. 8 plus 6 is 14, my mass number. And the simulation is telling me that carbon-14 is unstable. Since it's unstable, well, still 6 atomic number, 6 because it's carbon, 6 protons because it's carbon, but I put 8 neutrons in the unstable column. The mass number is 14. 6 plus 8 equals 14. And because this is unstable, I have to put a decay mode. Now you can do a couple of things to find the decay mode. If you are taking a Regents exam, most likely, I'd say over 99%, the decay mode will be on your reference table. N in the reference table will give you the decay mode. So carbon-14, see with a 14 in the upper left-hand corner, that's the mass number. Carbon-14 has a decay mode of, look at this weird sign, B with a negative. Well, what kind of decay mode is that? If you've forgotten, I know you remember because it hasn't been that long, but if you have forgotten, I could look right up here. Oops, right down here. Sorry, I went the wrong way. To table O, and that weird beta negative symbol tells me it's a beta particle, which is a beta decay. So carbon-14 has a beta decay. Okay, so you just keep doing that. You build lithium and you'll tell me how many neutrons are in the different lithium isotopes, what kind of decay they have, if it's unstable. If it's stable, like the first 2 are stable, there is no decay. Stable isotopes don't decay. Only the unstable isotopes decay, okay? So I'm going to do that there. Now, you'll use the PhET simulation for all the gray ones. Now, these green ones here, I'm telling you they're already stable. So you put the atomic number, the number of protons, the number of neutrons. All these neutrons are going to be in this middle column because all of these isotopes are stable. Then you'll fill in the mass number and the, no decay one, just the mass number. This last section here, these isotopes are all unstable. So you'll put in the atomic number, the number of protons, skip the column, and the neutrons go in the unstable column. Now, I think someplace, if you read this, I could have sworn I put someplace to make a graph. Yeah, plot the points using the number of protons on the X and the neutrons on the Y for the two different data sets. That means the stable and the unstable isotopes. Well, to do that, all you have to do is highlight these three columns, the yellow columns, insert chart. It's not going to do anything now. It's all weird because I have hardly any data in there. Change it to a scatter plot. Change the chart type to scatter plot. And basically, you will have your graph if you do that. You might have to modify it to include the axes titles, which apparently this one didn't do. But this looks weird because, the chart's not really filled out. But once it's filled out, it should look somewhat similar to this. It's not as big as this. There's not as many data points as this, but it looks somewhat similar to this. Okay. So that's filling out this chart and making the graph. What else do you have to do for this lab? Last but not least is, whoops, this should be taken away, is writing the nuclear equations. I guess I'll leave this here as an example. So you can do this on paper because writing the nuclear equations in typing on a Google Doc can sometimes be a pain. But from this document here, you'll have what kind of decay mode each of these unstable isotopes have. So I have beta decay for C14, which is the first one, right? If I were to do this on paper, I can show you how I would do it. And then you could, you can type it in if you want, or just take a picture of your actual paper copy and then you'll be, insert it into the lab and you'll be done. So the first one is carbon 14. So that is the radioisotope. When I write it to make my nuclear equations, I like to put the 14 on the top. There's a reason for that. And look it up if you don't have it memorized at all, but look up the atomic number or the number of protons and put that on the bottom. It's kind of important for this. Then I'll put my arrow because it's decaying. And then from the spreadsheet, remember we said it's a beta decay. And if you look at table O, you could write the beta decay with an E or a beta sign. And I'll put you need to put the numbers on there. So the top number is 0, the bottom number is -1. Okay, so that's for beta decay. Okay, so how do I figure out then what goes in this box, right? What goes in that box? You guys might remember that what we do is we will add up the top numbers and the bottom numbers, where the arrow sign is the equals. Okay, so let me make this a little bit more easy to understand. So I'm going to just take the top number right now. So the top number is carbon 14 equals blank plus 0. I know the math is simple, but I'm just going through it slowly so everybody gets it. What goes into the blank? Well, I'm sure you guys know 14 plus 0 is 14. So my element that I'm trying to find, I'm going to put a 14 on the top. Then let me do the bottoms. Okay, so the bottom 6, this is the bottom part. 6 equals blank minus 1. So what should go in the blank? Well, 7 minus 1 equals 6. So I'm going to put 7 on the bottom there. I wonder if I could erase this square. Yeah. Okay. So if I have 7 on the bottom, 14 on the top, what element do I put right here? Well, what element is element number 7? Let me go to my periodic table and look up element 7, which is right here. Nitrogen here is element 7. So on my, oh, sugar. I'm not showing my screen properly, so never mind. Let me do this. I want to find what my element 7 is. I'm going to my periodic table and find element 7 right here, right? And element 7 is nitrogen. So then when I go back to, oops, dang it. When I go back to my original whiteboard, if I could get there, did it delete everything? Nope. When I go back to my original whiteboard, what am I going to put here? But N for nitrogen. Okay. So then you see this is what I write. I would write on the table. C with a 14 on the top and 6 on the bottom, arrow, N with a 14 on the top and a 7 on the bottom, plus E with a 0 on the top and a -1 on the bottom, right there. And as you could see, my sample here, that's exactly what I've written, right? Can you see that? So you do the same thing for silicon 32, iron 52, xenon 135, lead 214, and radium 226. How do I know, did I go over this already? I can't even remember. How do I know what decay mode to put in there? I told you C14 and that was on table N, but what if it's not on table N? I am going to go to the chart on the Google slideshow, this one here, this chart on the Google slideshow, which is here. And if I zoom in, let's say I took carbon 14. Let me take carbon 14. Carbon 14 has six protons and 8 neutrons, while the stable has 6 protons and 6 neutrons. I think that's right here. Stable is here, 6 protons and 6 neutrons. The unstable has 6 protons and 8 neutrons, so that's above. See if I could, oops, what the heck did I just do? It's above the blue lines, right? So since it's above the blue line, if the dot is above the blue dots, then it's a beta decay. And I knew that because I looked it up, beta decay. If the number of neutrons is less than the stable isotope, then it's a positron decay. And if the number of protons, now this is protons, is greater than 82, that means 83, 84, 85, 86, 87, 83, 84, 85, 86, or 7 or higher, then it's alpha decay. Okay, so based on that information, you should be able to, whoops, fill out this section down here. So silicon 32 has 14 protons, 14 atomic number 14, but 32 means it has 18, 14 plus 18 equals 32. So 18 neutrons. So let me go on this thing. Silicon 14, silicon is 14. 14 is about here, and it has about 14 neutrons. That's stable. So 18 neutrons is going to be above. It's going to be unstable and a beta decay. All right, what if I don't want to hurt my eyeballs trying to look at those little dots? Can I do something else? Yes. I can click on this link here, and that brings me to the actual spreadsheet. Silicon is, whoops, silicon is 14, right? 14 is right here. These are the stable isotopes. Silicon has stable isotopes are 14, 15, and 16 neutrons, or mass number of 28, 29, and 30. So if I have 18 neutrons, I know it's higher, more neutrons than the stable, so it's beta. So if you don't want to see, what exactly are these dots, you can just look at this chart and look at the numbers. Protons are in the first column, neutrons are in the second column for the stable isotopes. And then based on if it's above, so more neutrons than the stable, it's beta. Less neutrons than the stable, it's positron. And 83 or higher protons, it's going to be alpha, decay. Again, those are only for the unstable isotopes. I know I'm repeating myself multiple times, but I just want to make sure I'm clear. All right, so that's it for the main part of the lab. So it's basically fill out this graphing template, plot these yellow columns, and then fill in the table at the bottom. And that's primarily it. I'm not going to really go over the root to stability, although once you've done the graphing spreadsheet, if you want to go back and try to fill out this root to stability, that's great. These are only 2 points out of the whole lab. So I'm not worried if you don't do that actual part. All right, good luck, and I'll talk to you later.